Aha! Right. Brilliant! Okay. So, as I was talking to myself, apparently I will start this again, but ladies and gentlemen, boys and girls, and everyone beside, between, and otherwise, welcome to Neve Engineering, and welcome to this live stream on MacFeegle Prime. It turns out that there was an incredibly ambiguous button I needed to press, which was Go Live. Never mind, eh? Right, so, brilliant, thanks Mark. Right, let's crack on. So, we'll start with the demo from PiWars itself, and then I'll go into a bit more details afterwards. Hopefully this time around you'll see an actual video. Presenting my entry for PiWars 2020 MacFeegle Prime. This robot is heavily inspired by Johnny 5, as you can see. It's a tracked mobile robot with 2 arms, each with 6 degrees of freedom, and a fully articulated head. His eyebrows aren't quite working yet, but I'm working on it. So the specs. This robot is powered by a Stereo Pi. This is a custom board that allows for dual cameras, as you can see in his eyes. Also one of the proud sponsors of PiWars. And the motor control is provided by Red Robotics Red Plus board. Also one of the sponsors, I believe. For the control of the arms, there is an Adafruit servo controller, not currently connected due to a compatibility issue. You can see the servo tester right there, just to make sure everything's working, and I'll show that in a second. The robot itself is running Ubiquiti Robotics Robot Operating System Image, which is based on Ubuntu. For the drive, we have 4 Monster Bog motors, which provide plenty of grip. We have 17 servos in total, 2 in the head, 1 in the torso, and the other 14 are in the arms. And we have 2 power buses providing power for these. We have a 12 volt, which is running the Pi and the motors, and there is a 6 volt power bus for the servos. Things to note is it's got a fully 3D printed design, including the tracks. So they're printed using TPU, which is a flexible material. The capabilities of the robot are actually extensible over time. So at the minute, the Stereo Pi cameras aren't actually being used, but they are capable with ROS of generating depth maps for mapping and obstacle avoidance, and line following, needless to say. The future plans using ROS are to create a kinematic model for the arms, to implement SLAM or use one of the libraries. And, well, one thing that's definitely missing, isn't it, MacFeegle Prime, is your weapons. So I've got a Nerf cannon that I've put together. It's not currently functional, but he's looking forward to having a play with it, to say the least. For one of the challenges, you'll recognise the barrel. Needless to say, the barrel isn't a problem. So I thought I'd give him a challenge and see what his maximum payload is. Not even the maximum payload. So this is a 200 gram can of peaches. Not even breaking a sweat at full extension. Thank you, MacFeegle. So, some ease of life features and functionality. One thing that is incredibly useful, it's a magnetic skull cap, so you can access the Pi and all of the other circuitry inside. One thing that is very useful is a charging port. So the battery pack actually has a BMS on board, which handles charging and discharging. So rather than having to dismantle the robot, I can actually charge it and power it at the same time. Very handy for when it's on the bench. As you can see, looking closer, the tracks actually have Morse code embedded in them as well. The dots and dashes there, as well as the blanks. It's not fully compliant Morse code. It doesn't have the pauses in it or anything like that, but I've only so many links to work with. As a tribute to the great man Sir Terry Pratchett, they read out GNU Terry Pratchett, so his name lives on. I just thought that was a nice little feature to add. So this is MacFeegle Prime, and thank you for your time. Thank you. I keep muting it and then forgetting to unmute it because I'm an idiot. I don't think anyone's really going to argue that, not too strenuously anyway. So thanks for the heads up on the chat. Thanks, Simon, I've got it. No need to shout. Right. So yeah, that was the video that I put in for PiWars a week ago, and that was the state of the robot as of a week ago. The thing that was most noticeably missing was control over the arms. I had a servo tester on the back of it, on his backpack, and yeah, we've got a lot further on than that. But what I'll do is I'll give more of a detailed overview of the robot, and yeah, take it from there really. So if anyone has any questions, pop them into the chat. I've got it on my monitor over here, and hopefully I'll be able to pick them up as I go. So yeah, this is MacFeegle Prime. It's based around a stereo Pi and a Red board from Red Robotics. You can see the stereo Pi down there, the two cameras up front. This has turned out to be an absolutely fantastic combo. I've got shaky hands, so let's put that back down. Just for the fact that it means I'll be able to have the stereo vision in there, and that'll be used for a combination of depth sensing using stereoscopic libraries in OpenCV, whatever else ends up working. But through the Red board, which I think the vast majority of PiWars competitors are aware of, you get control over servos. Where's my hand? Servos, motors, neopixels, you get power regulation, you get control over the motors, which has proven fantastic. I tried with various different bits I had lying around beforehand, and it was a nightmare, but thanks to Neil, that really has tied everything together. As you can also see at the back, we've got a fan. There's a bunch of heat sinks I added just because in an early version of this, it was massively overheating. It turns out there was a problem with the stereo Pi board itself, and I got in touch with them and they sent me a replacement, and it's been absolutely perfect ever since. I need to send the old one back to them, but again, the world was on fire, so I haven't been able to get to the post office yet. So, from his head, we have the Raspberry Pi, which is a compute module under there. We have the Red board, and then we can move around to his backpack. So, we've got a 10 amp buck boost converter, which takes a feed from the humongous battery that's underneath. His head just fell out. That is all battery. It's a 3S6P module that I built myself, and it has a BMS on board, a battery management system. So the idea is there's a charge port down here, and I've got a big 12 volt power supply, one of the 30 amp ridiculously over the top ones from an old 3D printer. You can plug that straight in and it'll charge on the robot and it'll actually power everything at the same time. And so far that's worked absolutely brilliantly. It just means that if I want to be hacking on it, I could just run it from there. And the power supply actually has more than enough power to power the motors and all the rest of it as well. So with a long cable, which it has, it can just drive around on mains power essentially, just for testing and whatnot. So we have the power supply down there. We've got a power switch there, which I'm not going to hit because it'll probably rip his own arm off again, unfortunately. And we've got the umbilical that goes up into the head. So there's the 12-volt raw feed that goes straight into the red board at the top for controlling the motors. It has a power regulator which powers the Pi and 5 volts and all the rest of it. So we have those two power buses, one at 6 volt and one at 12 volts. Now, as it stands, he has 16, 17, 18, 19 servos on board, because I'm a glutton for punishment. 3 of which are controlled by the red board. So you've got the 2 for the head controls for pan and tilt, and then there's one more in the torso down here, so you can stand up and lean down. Which, when it's got no power on it, it's not very healthy. And yeah, Mark has just asked why a compute module over a full-blown Pi. Because that's what came with the Stereo Pi, essentially. So the Stereo Pi is based entirely around the compute module. So the compute module has an extra channel bus. I'm not sure what the exact wording should be, but it can support 2 cameras natively. So they built essentially a breakout board around the compute module. And yeah, that's it really. So that was the entire thing. And this way it means I've also played with, until they announced it, all of the different variants of the Raspberry Pi. So I've got 1s, 2s, 3s, 0s. I don't have a 4 yet, and I now have a compute module. So yeah, just for the completionist in me, that was the reasoning there. Thankfully, the Stereo Pi board itself handled all of the connectivity. It's got... we can remove his eyes, so that's another thing I was quite happy with. So you pull his face off, which still feels a bit grim, but you've got access to the micro SD card, Ethernet, a pair of USB ports, and the HDMI port, so you can actually do full debugging and all the rest of it if you wanted to. There's also another header on here somewhere for USB, and I've got a little USB hub that I've slowly been shaving parts off, and it'll basically sit behind what I've affectionately named his ass flap. So the power switches and the charge ports, it'll actually have a couple of USB connectors as well there, just for any extra peripherals that I need to plug in, because there's limited space there. So, we've talked about the Stereo Pi and the red board, and we were talking about the arm controls. So, the red board has what for most people would be an incredibly generous 12 servos, which clearly, yeah, wasn't quite going to cut it here. So what I ended up going for was an Adafruit PWM servo board, and this one's generic in that it's basically an I2C adapter or interface board. So yeah, you plug I2C into it and power down the bottom, and then you've got 16 PWM channels that you can address. You can daisy chain these to have up to, I think, 64 boards in series or in a link. Even I'm not going to go that far. But the idea is this will... Well, the first idea was that this would talk directly to the Raspberry Pi. Unfortunately, this board requires use of the Adafruit Circuit Python something specific library for this and similar boards. Now, this works perfectly on a full-blown Raspberry Pi, but for whatever reason, it just flat out won't install on a compute module. So the the next step after that, and one I was going to kind of go with in the long run anyway, was to add in... I had plans for loads of props, and they're all AWOL, because my plans tend not to survive first contact with the enemy, which is me. So, the idea is, and a lot of other competitors will attest to this, to have the Raspberry Pi as the primary control and kind of oversight mechanism for the entire robot, and then for more real-time operations like checking sensors and, in this case, controlling servos, have a secondary microcontroller which is dedicated purely to doing these real-time tasks. Very common paradigm for mobile robotics in general. Currently, I have an Arduino Mega. I do have a Teensy somewhere, replacing the one that I kind of popped. Apparently, it's a rite of passage to kill Teensies for PiWars, but you know, I'm there now. And basically, I didn't have time to solder it and get it attached. But with this, as of about an hour ago, I was actually able to get control of the arms. And basically, it's just been lots of fiddling, finding the center points for each of the servos, figuring out the frequency for the internal oscillator for the board as well. For whatever reason, they're just slightly... every oscillator is slightly different, so you have to tweak it in until the arms basically behave as expected. If it is a standard I2C servo controller, and the source code for it is out there, but frankly, I got this one so that I could use somebody else's library. I know I've already bitten off too much, well, more than I could chew at the time to build this in general, just for the concept alone. So yeah, where I can get something where someone else has done the plumbing, I'm going to grab it with both hands. So yeah, the plan is to have a Teensy that, in the same way as on the controller, it's acting as a ROS node, which I'll get to in a second. So it'll be sat there listening for arm control commands. So, you know, set right shoulder to this value, which you can just about see on the other camera, and so on and so forth. But the other aspect of this is sensors. So you can see these bays down the side. These are actually something that I started doing later on than I should have done, which is making it a bit more modular. So rather than having sensors designed into these side pods, which would have to be redesigned every time if I needed to tweak the angles and things like that, I made little bays where you could just screw straight into them, and if you needed to tweak them, you could reprint a part that takes half an hour or something like that, and just swap them out. Because apparently the time of flight sensors can be quite tricky with regards to what they pick up, and they can detect the floor as a wall. So yes, and I don't know if you'll be able to see it, but you can't see it. There's the Raspberry Pi and the Stereo Pi and all the rest of it actually sits in a caddy. So rather than having to reprint the head each time, yeah, I've got like 4 or 5 spare heads, more than Crichton does for sure. And yeah, it's just a waste if nothing else. But so yeah, so we've got the Teensy, which will sit on the backpack, which will control the arms, and it'll also take in information from the various sensors, and that's then basically fire it up not only to the Raspberry Pi but into the ROS, the Robot Operating System architecture, so that it'll be forwarded onto everything that's listening. So regarding the architecture, as much as an excuse to learn it as it is to actually be a useful system, I thought I'd go use this as an excuse to learn the Robot Operating System. So despite its name, it's not actually an operating system. It's more like an SDK, a software development kit. And it is at its core, and I will say I'm self-taught on this, so everything with a pinch of salt. It is at its core a messaging system. So you have subscribers, which listen for messages. You have publishers, which publish them. And you have different topics. So you can have, for example, on the controller, the custom controller I made here, This has a teensy inside, which I think we need to get a bunch of stickers made in that regard, and a Raspberry Pi up top. So the teensy is hooked straight into the Raspberry Pi. This connects to the same Wi-Fi access point as the robot. And the idea is that the robot acts as a master node for the robot operating system. And this and any other controllers or receivers or telemetry monitoring systems can, they can all hook into this same system. And the teensy broadcasts directly using something called ROS serial. So ROS serial is a serial package which basically lets you hook microcontrollers into another computer, in this case the Raspberry Pis, and it allows the microcontroller direct access to everything else. So rather than having to send a message to the Raspberry Pi saying, right, this joystick has done this, and then the Raspberry Pi will then interpret that, repackage it, and send it back on, it can basically create a message directly from the microcontroller and fire it directly to where it needs to go. So in the case of the ARM control, the teensy on the controller will actually say, right, add this value to this joint on the ARM's servos. It'll get sent to the controller, it'll then get passed over to here, and it'll get passed straight through to the teensy on board here. So to a certain degree, the Raspberry Pis will be acting as a bridge. With that will be in the first instance when I have manual control over the ARMs. The actual goal, though, is to use some of the more powerful aspect of the robot operating system, which are modules. So ROS has been around since 2007, and it's been developed and developed and developed, and it's now used on lots of different mobile robots, and it's kind of industrial grade to a certain degree. Well, no, to an actual degree. And lots of people have written modules for this, including something called the MoveIt Kinematics library. This is software that you can hook in to the software architecture of your robot. And you can say, right, this robot has 2 arms. It has 3 joints in the arm, and you can specify this and the length of each part of the arm, for example. So the upper arm, the forearm, what degrees of movement, what degrees of movement it has in each axis. And rather than saying, right, okay, I'm going to move my arm, I'm going to move my elbow out slightly, and I am going to open my hand, then I am going to move my whole arm down, and I am going to pick up. That's not how we think, if nothing else. We say, right, I'm going to move my arm forward, and I'm going to grab that. So what this MoveIt library will do is something called inverse kinematics. Now, maths are a necessary evil, but there's a reason I didn't get past the first year of cybernetics, which was maths. I'm more about how you actually do things, the application of them, and rather than just the theory, and sadly that didn't happen. So with these inverse kinematics, what you can say is, right, I want this to basically intersect with this X, Y, and Z coordinate. So rather than me saying, right, move this one forward, then move the elbow down, and then rotate the wrist like that, and then, oh, look, you're there. The kinematics library will go, right, I know what all of these are. Let's solve this equation and move to that location. At which point you can start using the joysticks, which are 6-axis, 3-axis. Get sued by PlayStation now. So you have forwards and backwards, left and right, but with these ones you also have rotate. So the idea is you'll be able to push forward and the arm would move forward along that plane rather than just moving like that. So you can actually then press and hold this button. So say if this by default is moving the arm around in arm control mode, by pressing and holding this, it might be you then get fine control over the hand. And that's one of the powerful features of the robot operating system, is that you can adapt it to your needs. There is a learning curve, and as soon as I figured out that it is just a messaging system similar to MQTT, I don't know if it has queuing. I don't think it does. But yeah, at which point there are then all of the libraries available, all of the languages as you'd expect. And yeah, you can. I managed to get the controller using Rust. So currently we've got the head control and the motor control, and like I say, he ripped his own arm off last night, so I'm not going to risk switching it on right now. And those are just two different nodes running on the Raspberry Pi, on the Stereo Pi, and yeah, that's kind of the overview of how this works. Let's have a quick look at the questions. You wish your project only needed 12 servos. Yeah, that's... I think the original design I had for this was somewhere in the region of 23, because the gun was going to come over his shoulder and have a couple more, and then it'd be able to move and all this sort of stuff. I'm still going to add a few more because I want to get the eyebrows actuated, which will be just for a laugh. But yeah, so will you have the Teensy PWM, the ARM servos directly? Oh, it'll still be via the Adafruit board. So the beauty of the board is that you can say, right, set PWM to this value, and then the board will just do it because it's just a PWM controller. So rather than having to keep it running, you can just say, right, lock into this position, and then the Teensy can carry on doing something else. I mean, it runs at 120 megahertz, so it's going to be over-spec'd for this anyway, but the Teensy 4 that's in the controller runs at 400 megahertz. So, but still, you know, if it works, it works. So, next steps. So, where are we going next with the robot? One of the things I've sort of spoken about is the fact that we've got the stereo cameras up front, and there's already an Android application for the Stereo Pi that allows you to hook in to the feed coming from them, so you can actually get just a stereo feed into a Google Cardboard headset, which is right here. Ooh. So Google Cardboard, which has now been, I think, cancelled essentially by Google themselves. The idea was to literally make a VR headset, and the first versions were literally made out of cardboard. And you've got a place to hold an Android phone and a couple of lenses in there and a separator, and you essentially it uses side-by-side video, and then the Mark 1 eyeball, your eyes and your mind just do the rest. It generates the sense of depth, and you can watch 3D videos in this, so you can actually move your head around and you can look wherever you want in the video. Loads of those on YouTube, and this is quite a nice, simple, cheap solution as well. I just liked the elegance of it to a certain degree. I mean, don't get me wrong, I've got an Odyssey VR headset over there. I use 5 at work, and for real-time-ish 3D generated worlds, you can't beat them. You really can't. But this cost nothing. This actually came free in a box when I bought something else online. And I've got an old phone. So I thought, let's see if we can take this to the next level and go for some kind of actual telepresence control for this. So those of you who follow James Bruton of xrobots.co.uk, you might have seen his performance robots that he's been working on, where he actually has a puppeteering rig that allows him to allows anybody just to grab hold of them and move the arms on the controller, the puppeteering rig, and the robots will mimic it. The idea is that you'd be able to have somebody in the crowd or the audience actually controlling these robots in a more controlled manner. To that end, I've basically completely taken the idea and which way around are you? And I've created this. So let's switch cameras because this will be a bit easier when it's just me. So, and there you go. Someone has my fingerprints now. Right. So the idea is you have this, which will be, this is one arm of 2. So there'll be another one over here, and it'll actually sit on a little stand in front of me or on a lanyard type thing. And the idea is that there's one potentiometer for each of the joints in the arm. So you can actually move the arm around, move it forwards and in all of the axes as you wish, and basically just by holding the handle,
Had to get a pun in there somewhere. The robot will mimic the movements of this. So rather than having to think about, just using controllers when you've got your eyes completely covered up, you can basically just quite intuitively move these around like Waldos, I think they call them, with remote operation. They're quite common in situations where you've got to control robots handling radioactive materials, for example. You'll see them in sci-fi films and all sorts of stuff. I'll be wearing the VR headset, and I'll actually be able to see the arms in 3D and move around. And yes, where Torodyne were planning on doing, doing all of their challenges autonomously, other than Lava Palava, which is mandatory autonomous because it has to follow the line. I was planning on doing, and still planning on doing, all of the challenges through the VR headset. So yeah, it'll all be teleoperated, and it'll be me in the arena actually driving around because why not? I mean, I've wanted to build a robot for a long time, and this is just a wonderful excuse to go completely overboard. So that's the next step for the control. So as well as being able to use the Kinematics library on the actual custom controller, we'll be able to use this as well. Or even both. So it could be that you've got one person with the controller, they're actually driving it around, and you've got somebody else who has the VR headset on, and they're actually controlling the arm. So you can shout, right, go forward, right a bit. Or the other option, which I can't remember the name of the robot, but Naomi Wu, aka Real Sexy Cyborg, she did a video not long back of these little robots you can get that drive around, and you can hold a shield and they thwack things and they fight each other. She showed off the controller for that, which is exactly this. It's got the you can move the hands around to puppeteer the robot, but it also had in the base of this controller essentially a joystick, so you could move it forwards and the whole robot would actually move as well. So I'm investigating different ways I can actually have all of this control just in one thing, and depending on how much motion sickness it'll give, possibly even move the head around and control the head and things like that. So that's the future for the control of the system. Now, one of the other things is the robot itself in its current incarnation has 6 degrees of freedom. Still doesn't have the hands attached. I'm still working on the grippers, but I'm going to show you those in a minute. So, as it stands all the way to its wrist, it has the same number of degrees of freedom as the human arm. So, you've got one here, which I refer to as the flappy axis. It moves. Well, why don't I just move the robot? So it moves in and out, side to side. And I don't know what this axis is actually called on the human body, but the flappy axis just works for me because it flaps around a bit. You can then move forwards and backwards, and it can rotate here as well. The same as your arm can do. And I'm wondering how many people are doing this at home right now. You then have the elbow, so it can move around, and you can move the elbow in and out. There's then another axis of rotation here, which is that. And as it stands, we then have upwards and downwards. So if you want to go and pick something up, I'll say this, for example, if your wrist can't rotate, then your arms won't be able to match the position of the thing you're picking up. So the idea is if you can just give the robot a bit more movement like that, it had a better chance of picking up all the barrels. Now, why stop there? I wanted the full 7 axes, and so far we've got 1, 2, 3, 4, 5, 6. As is too often the case, at about 3 o'clock in the morning, I've had the idea, and it was actually, as Mark mentioned, hacky races earlier, it was thinking about steering. And Rory Mangles, he's got a beautiful and astonishingly scary hacky racer, hackracers.co.uk, look us up on Facebook, and shameless plug. It uses a universal joint from a socket set. So the idea is you can just pull the steering off for ease of transport, and it just uses like a 1/4-inch plug, I think it is, from a socket set. So that's where this comes in. So this is the newer version of its wrist, and the idea is that you'll have one servo here, and I'll tell you what, let's see if this works. Desktop, and wow, you can see into infinity. There we go. Right, so this is, and don't judge me with how messy the timeline is in the browser. I know it is, and it causes me nothing but pain. So the idea is that we have the universal joint here. One axis will be controlled by this servo here. So that is, which camera are we looking at? That is this one here, and it will basically control the up and down movement of this joint as the robot already has. If you move over to here, we then have another servo on top, which will control the other axis. So it's basically on the other side. The servo will be here, and as the servo moves, it'll be moving the hand around like that. So you'll get the full upwards and downwards, and the left to right, which we don't actually have that much movement in, but I want it, so I made it happen. Needless to say, again, completely overly complicated, but that's kind of my MO, as you may be realizing. So that's the idea behind this extra universal joint. I've not actually finished getting one built yet, but most of the way there, and I'm quite confident it'll work in some form. So while we've got this up, we may as well have a look at the hand mechanism itself. So we have another one of the servos here. These are the 9-gram standard servos. You can see, these are the cheap ones you get with Arduino kits. The ones I'm using on the robot are actually a slightly upgraded version. They have metal gears, just for that bit more strength. And the idea for the hand is that you can see here these little holes. They are actually I can't see the chat, just in the off chance this is working. Good, I still have audio on RS, yeah. So these, let's do a section analysis. I've actually designed in these little challenge, yes, a challenge. It's a challenged Allen. These channels, and the idea is that you can put some high strength thread through there, and you'll be able to basically pull on the end of the finger, and it'll draw it in. Now I have one of those working, ish. So this is one of the prototype fingers. Oh yeah, I'll just show you the other side. Let's cancel that. Oh God. There we go. Right. So as you can see here as well, we've actually got these tiny little things, and they're like little mushrooms inside these channels. What they are, and this isn't a version of the hand that has them, which doesn't help. Essentially, you can hook elastic bands around these holes, and then between each joint, and they basically pull the finger taut. So the idea is that the fingers will always be out, the hand will always be open, and there's a pulley attached to this servo, which is behind my face. So there's a pulley here, and there's this one here, which goes onto a spindle with 3 holes through it. And the idea is each of the fingers, 2 fingers and thumbs, before someone points that out, will have a line attached from this central shaft thingy. Very technical term there. And as the servo rotates, it will draw those in, and it will slowly pinch the hand closed. So that's how the gripper will work, and how I'll control the wrists essentially. So let's switch back to that one. And there's pretty much just one last thing to talk about, and pretty sure the estate of Steve Jobs is going to be after me for some money for using that phrase. There we go. So, let's move that back over here. One of the things this robot can do, or is slowly being able to do, is move its arms around. And at the minute you send commands to the arms or to the servos, and they then do a thing. You have no idea if that has actually happened or not, because you don't get any feedback. Now, there are some expensive servos that allow you to get not only set the position of the servo. Servos are essentially a potentiometer similar to these, so the servo knows its value there compared to what the pulse is that comes from your microcontroller, and that's how it sets a position, or for a continuous rotation, the speed. Now, those expensive things, basically all they are is they've got an extra lead that comes out, which allows you to get the value from the potentiometer directly. So you can get some feedback that way. Now, this is one of the chunky servos that I'm using in the upper arms and up down to the elbows and in the head. And essentially what we've got here is the chunky motor at the back, if that want to, yeah, so chunky motor in the back, lots of gears out front, and embedded deep in there, which you're probably not going to be able to see. Come on. Yeah, it's got fixed focus, hasn't it? You've got the 3 pins, which are the back of the potentiometer. So I very loosely hacked in an extra cable. And the idea is that, let's put this together before all of the gears fall out and I cry. Over time, I'm going to go through and modify all of the servos so that I actually get these values out. And there'll be a couple of benefits there. For one thing, I'll actually be able to get feedback as to where it is, such that, and anyone who's used servos will know this, if you switch them on and give them power, and say, for whatever reason, the robot was left like that, it will instantly set the values to whatever the controllers told them to. So they'll just all snap into place, which is essentially how he ripped his own arm off last night. I was going through one by one trying to find the center point of each of them, and this arm basically tried to go through its body while the elbow was pulling in as well, and it just ripped its arm off. With this feedback from the potentiometers on board, the first thing I'd be able to do is, right, what's the position of all the limbs? And it goes, okay, right, interpolate safely to those positions. This is referred to as compliance, as I understand it. And yeah, it means that I'll be able to actually have feedback against all of these things. So as well as knowing the positions, for example, if he starts picking something up and I've said, right, servo, you go up to that point, but the arm isn't actually moving, you'll know that it's too heavy. So you'll be able to get some feedback with regards to if the limbs have stalled. And that's the first place I'm going to do that is actually in the grippers. So by putting one of these feedback or hooking into the potentiometer in the servo, I'll actually be able to see, if I slowly close the hand and wait to see when the potentiometer value stops changing, I'll know that I've gripped hold of whatever it is I've aimed for. So if I'm picking up the barrel, it can stop there. If I'm picking up something smaller, it'll go in, and so on and so forth. How am I going to relate the potentiometer value to angle and servo pulse? That is a very good question. Future Keegan has an excellent answer for you. I think at the minute I'm basically going to go through and have some kind of test sweep so I can say, right, spit out to the serial port the potentiometer value and the value that I've put into the servo, and basically do it manually. I don't doubt there'll be some fancier way of doing it using calibration, and I'll over time because I've never done anything like this before. Bizarrely, this is other than a Roomba I hacked. This is the most complex robot I've done by any stretch. And yeah, so over time, all of the capabilities will develop further. Very typically along the lines of how lazy am I feeling, and is it easier to develop something to make my life easier? Any way to add limit switches type things as a failsafe? Yes, that's entirely possible, but in the same way that stepper motor controllers for 3D printers, they're moving towards it's something called stall guard they have on the Trinamic series. The newer 3D printers actually can tell when the stepper motor has hit its limits. So, for example, they'll just like literally slam against the side of the axis, and they'll detect that they've stalled, and that's how they figure out their end stops. And I'm just going to go with this because it's a bit more complicated, and to a certain degree the potentiometer's already there, so I may as well just use it really. So it saves on trying to figure out how to add in yet more components into the arms. It is a very, very manual process, essentially, especially with this PWM controller, because it is primarily a PWM controller. So you can't say, as with the Redboard library, you can say go to 90 degrees, 45 degrees, and so on. I don't doubt for a second if you dig in, there's actually a library that converts that to pulses. So yeah, adding that is the very much kind of the last of the planned features, which, let's face it, I didn't plan half of this. So I think that's a good overview of the development of the robot, what it is, how it does it, and all the rest. And holy crap, I've been talking almost an hour. Right, I suppose, any more questions, fire away in the chat. If this is something people have been interested in as well and actually followed, I'd be happy to do more of these, not once a week, because that way madness lies, and I've got enough of that already, as you can see from the robot. But I'd be more than happy, like once every few weeks, once every month or something like that, just showing updates on the road to PiWars XX plan. The MacFeegles love a plan, don't they? So the plan is to finish off design of the wrists, finish off design of the hand, to actually integrate them into the controller, the custom controller, in the very basic way. So to start with, I'll just use the different modes by pressing the joystick button. Each of the 3 axes will control the shoulder in normal mode, and then press the button, hold it, it'll control the elbow, for example. So that's the next step for the controller and for the arms. Then after that, it'll be getting my head around how to integrate the Move It Kinematics library. There's loads of examples out there, so hopefully that won't be too bad, and it looks like one of the most used libraries for it as well, so hopefully that'll work a treat. The line following is one thing it can't actually do. So this being an intermediary robot, bizarrely, needless showing how ridiculously complicated it is, the only one it has to do autonomously is the line following. So I think Brian put up some slides from a talk at Cambridge Raspberry Jam a while back. I do try to plan. Not planning is what got me in trouble to start with, but it's a skill I'm learning through this project, I assure you. I forgot what I'm doing. The Kinematics library. So so it only needs to do the one task autonomously, and Brian put up some slides on the basics of how to use OpenCV on the Raspberry Pi. So I'm going to look through that. By all accounts, I've heard good things about the talk, so I should be able to get my head around that and get him actually following the line using the eyes, at which point the rest of the sensors aren't as much of an issue, but it'd be nice to have them just for completeness, if nothing else. And yeah, then the gun. I guess that's the one big thing that isn't here at the minute. You would have seen in the video at the start, but this is his gun. And it's completely ridiculously over top, as all robot guns should be. And the idea is he'll be able to hold on to the actual handle here. You can't really see because it's side on. There'll be some kind of mount on his shoulder for this to rotate around. So he'll be able to pivot it up and down. If he needs to move left and right, he'll just move. And I think this is just under, by about a few millimeters, the maximum length we can have in a robot. At which point he'll be ready for war. There's too many puns there, Mark, and there may be children watching. But yeah, it's go big and stay home, I think is the phrase of the day at the minute. And I think that's pretty much covered it. And no doubt there will be problems en route. Plans change because they always do. And yeah, we'll just take it from there, really. If people want to follow, subscribe to the channel, because I'll put more videos up and schedule things in advance. I'm guessing pretty much everyone on the... It is a rocket launcher at that scale. The actual gun mechanism ends there. So all you need is the flywheel and the thing. That is completely superfluous. But it's also a really nice place to put the handle on and the laser sight, because you've got a lot of lasers. Yeah, so follow me here and follow me on Twitter at Neve Engineering, same on Facebook and all the rest of it, as updates come out. Don't have the cameras are basically connected at the minute, Mark. Mark has asked on the chat, do you have any stereo video recording yet? No. I've taken pictures from early prototypes to actually just make sure it all works. But yeah, am I going to give myself a break? Ish. So I'll be taking it steadier, but I'm going to carry on working just because, if nothing else, I've got the next week off work. And strike while the iron's hot. So what I'd like to get working is the wrist and hand mechanisms and the controllers, just so that I've got it to a point of vague completeness for all of its drawings and things. And yeah, because otherwise I know in 6 months' time when the new date is announced, like, oh, where was I? I can't remember what I was doing. And I like the idea that when the dust settles and everything reopens, I can actually take this into work and show some of my colleagues, because they've been following this as well. But yeah, if there's no more questions, I think that's about it. If you do have any more questions and you're watching back the recording of this, feel free to either leave a comment or put them upon the various things. Another question in from Mark. How are the tracks holding up? Have you tried them on a sloped or rough surface yet? I actually had the robot go up the garden path. I had this whole video planned out for PiWars where it was basically doing a rocky training montage, but seeing as I didn't get things working until an hour before the deadline for the video at 9 a.m. on Saturday, I didn't have time to finish that. But yeah, the slope of the garden's about that sort of thing. The tracks came off. I'm not going to lie. I'm not going to say they're perfect. The original design was that they're all 3D printed. They're TPU, and they have between either side here, they've got little divots that lock into each of the next ones. I ended up, I don't know how well that'll look. Yeah, there we go. Basically hacking up an inner tube and taping it to the inside. But the tracks can still separate. So I definitely need to rethink the design of the tracks. But the reason I added the strap in was because the power of the motors would just rip them apart anyway. And I've seen enough Scrap Heap Challenge tracks always fail. So to mitigate that, the drive wheels for the robot are actually printed in TPU as well, so they can actually just act as wheels. So when the tracks come off, it can carry on moving. I didn't put all my eggs in that one basket. And yeah, for those intrigued, where's the start point? So one of the things I was determined to put in was a homage to the Curiosity rover. So you've got dot dot dash dot dash dot 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 dash space. These spell out GNU Terry Pratchett as a homage to the great man himself, with a few other little things in there for my own enjoyment as well. The name MacFeegle Prime, it comes from a very sleep-deprived moment where I was looking at Eagle Prime, the Megabot Mark III, just to get an idea for how they'd use their arms and how they attack the guns and things like that. And MacFeegle Prime just came to mind, at which point a whole story opened up, which is what would happen if Johnny 5, devoid of input, ended up on Discworld with the Feegles, the We Free Men, rather than with Stephanie. So come PiWars, he's actually going to look quite different, as you'd expect from a robot that has been taken in by the We Free Men. So it'll be a lot more blue. He'll have a spog, very much have a, damn you, floof, a mohawk as well, and various other randomness, possibly even a little shield, because why not? So yeah, that's where the Pratchett link comes in, and no one truly dies while their name is still spoken. So yeah. Alistair said, have you thought of filament switching mid-print? Yes. I actually have the multi-material upgrade for my Prusa, which I've completely failed to get working, and I don't actually know if it supports TPU yet, but I know that in the slicer you can actually say stop at this point, change settings. It's something I want to look at further for sure. The design on which I'm basing these tracks, which is in my blog somewhere, it's printed in PLA, and the hooks actually work a lot better. So it's one of the many things that really needs improving, because I'm determined not to lose the Morse code. So yeah, I'm gonna call it there. Just because I've said goodbye that many times, it's not quite quite landed. Any more questions? Feel free to put them in the comments, and I'll address them afterwards. I hope this has been informative, and I look forward to seeing everyone at actual PiWars rather than virtual PiWars. And later this evening, hopefully the results from virtual PiWars will be announced as well. So head over to @PiWars Robotics, I think is their handle on Twitter, and piwars.org, which is their website, for more information on the competition itself and the rest of the competitors. Some of them are absolutely fantastic. I'll not name one because I don't want to play favourites, but watching the video from PiWars last weekend was absolutely superb, seeing all the ways everyone had solved problems. So thank you again for tuning in. Yeah, never quite sure who's going to turn up. But yeah, this has been good, and bye for now.